Hello, and welcome to Func Prog Sweden, the last for this year. We are super thrilled, as we're finally having an event live from Funnel. It's super nice. So, over to the agenda for today. First we do an intro by me, then we have proper state machine testing by Max Nordlund. Banking on Clojure by James, and then we're soon Christmas. We'll have like the debugging carol, bugs past, present, and future by Emil. And in the end, I will do a summary and the schedule for the coming year. Yeah, there will be a new year next year, believe it or not. But first, I would like to say thanks to our venue sponsor, Funnel. And with me from Funnel, I have Ville. Welcome, Ville.
Thank you. And at Funnel, we care deeply about functional programming. And to put it in words suitable for a functional programming meetup, I will cite Eric Norman's great new book, Grokking Simplicity. We care about your data, we care about your calculations, but we leave your actions on your data up to you. Thank you.
Thank you very much. And then we would also like to thank our video sponsor, Otherbeat. Otherbeat is a small IT consultancy company where most of the people actually have a background in functional programming. Yes. And if you want to support the meetup or the community, which you of course want to do, join the meetup group now. Follow the YouTube channel. And check out the merchandise store and buy a cool t-shirt with the logo on to spread functional programming. If you have questions during the presentation, please use the chat. I will read up all chat stuff. If you're in this room, please wave an arm and we'll give you a microphone so the people on the stream will also hear the questions. Yes, with that said, let's start. First presentation in widescreen. Or welcome up on stage, Max.
Thank you.
And your presentation. Now we'll do the magical switch of laptops. Let's see if it works. Here you go.
Thank you. Okay. Okay.
Oh.
Can you see my presentation? I don't know. Tech crew. Are we good? Lovely. Hi. My name is Max. Hello. Thank you. I work at Kivra as a backend developer, and we mostly write in Erlang. We also use other programming languages, I promise. And I'm in particular, I work with Kivra for Business, and by that I mean Kivra for Business for receiving stuff, not for sending stuff. And we like state machines a lot in my team. So I'm going to talk about state machine, both in general, and more particularly how to test it in Erlang using a property testing library called Proper. So, the plan. What are state machines even? How can you use state machine as a design tool, aka how to teach a product owner to think in state machines? An example, we're going to look at a user lifecycle, and by user I mean like a user account on some sort of website or something. Every good presentation has a demo. It will probably fail, but it's still hilarious. And questions, of course. And finally, the most important, funny animations. Hell yeah. Okay, so what is a state machine? There are many different definitions. If you look at Wikipedia, you get into finite state machines and automata. And it's very nice and it's very formal and it describes like the properties and how it's in the computational power compared to a Turing machine and stuff like that. And because it's limited, it's not a Turing machine. It means that we can prove stuff about it, and which is why mathematicians and programmers like them. I'm going to use this definition. There's a finite set of states and a finite set of transitions between them. This set of states and transitions is what makes up a state machine. You can also imagine it as a diagram. You have some boxes, you draw some lines, right? Those are transitions, those are states. The idea is that by forcing you to look at your problem and your domain and write down it in terms of states and transitions, it means that you can be very precise in what you mean. It means that the product owner and you are much more in agreement of what is what, how something should work, and so on and so forth. In fact, when we started like describing the Kivra for Business part using state machines, our product owner at the time, he discovered a new state because he was thinking about an edge case and realized that that edge case wouldn't fit within the state machine that we had. So we had to add a new state to the state machine. And it's really good. It really gives you a lot of precision, and you can do that while drawing on a whiteboard without actually programming, right? You don't need to be a programmer to do a state machine. Yes. Stuff that you can describe with a state machine: the user. You can describe a cart ship, or like a checkout flow. You can describe a truck. It has also states: working, not working, maybe a few other. There's a lot of stuff. State machines are awesome. I'm gonna say something. Anything with a life cycle is a state machine. And that means that most stuff have a life cycle, and it's really obvious. Like if you have a customer, you have a customer journey, that's a life cycle. If you have accounts, if you have customers, everything, if it has a life cycle, it has states and transition, that's a state machine. And now you can formalize it, you can code against that, you can make contracts with that. You can, if you use a static type language, you can even enforce that at compile time using clever gymnastics, usually. I'm going to show how to do that using dialyzer in Erlang, so you can do that in a more low-key way. But if you use Rust, you can have an enum for the different states, for examples, stuff like that. It's very nice. And as an example, as I said, we're going to talk about the user lifecycle. Show me some states. And funny animations. Anyway, so incomplete, pending confirmation, active, and grace period are the ones that I've chosen. These might not be the ones you expected. Again, this is to prove a point that it might not be obvious. We all have different expectations. I'm going to talk about the user lifecycle, not necessarily what pages the user goes to in order to sign up, right? This is more abstract. This is what we want to model, like the domain. So the first one, incomplete, that's during sign up. We want to be able to create a new user even though they haven't finished signing up, to be able to store their work as they're signing up. Hopefully you have like 2 fields and you don't actually need this because you want to sign up users really quickly. But if you need to fill in more, if you have it to do it over time, maybe you need to gather signatures. Maybe you have to do that according to signatory rules, firmateckningsregler. You know, you might be in this incomplete state for a while. So we have incomplete as the initial state. Pending confirmation, that means converting their email. You know, the classic, please check your spam box as well. Click on the link. No, that sort of stuff, right? So first we incomplete, and by incomplete here, I mean like fields, like name. You have to fill in your name and stuff like that. You have to fill in your email. Then we wait for you to be confirmed. And once you're confirmed, you're active. Everything is hunky-dory, steady state. This is where we want to be. If a user wants to exit, right? They don't want this anymore. We need to be able to model, like either we do a hard exit, we did all this stuff, boom, shakalaka, everything's gone. Or we need to have some sort of grace period, right? Where we keep the data so that you can retrieve it, so that you can change your mind, you know. Maybe we need it for legal reasons. Maybe we need to do a final invoice to make sure that you not owe us money. That means that the grace period might be very long, depending on how long it takes for you to settle your debt with us. You know? So we have entered a grace period, and then at some point in the future, time-based event here, something has to change, right? In our case, I don't have modeled like the extra exiting. I haven't modeled a pure init state. If you want to be really like abstract, you can imagine all the users as a set, and then each user each user in the set have a state. And the first state is that the set of everything that's not your user, a non-user, right? So in our when we are modeling our states, they all start with no user or no, like the opposite, so that we can model everything in the same state machine, even the ones that does not exist in our system. But I don't do that here because that's kind of bonkers. Anyway. Have I have some transitions? Okay, this is hilarious. Yeah, people on the internet. So the screen here is actually divided by 6 different TVs. And so my lines, those arrows that you're seeing, they are literally on the line in between the screens here. Anyway, here we have some transitions, as you might kind of guess, I guess. Or if you're on the internet, you can actually see them. Again, as I said, this is kind of, no surprises here. But we actually have some more state transitions that are valid, because you can change your email, you can change your name, right? Which means that you can go back from being active to needing to confirm your email again if you change it to an email that's new. Or you go back, if you change your name and make it blank, that means you're incomplete. We have to go back all the way to incomplete. Of course, this might not be, super useful in the real world. Maybe you don't, accept not entering a name. But at least the active to pending confirmation, I think, is actually kind of same. But I wanted some more arrows because that's more fun. So here we have it. Some states, some transitions. If you go to a grace period, you can never get out, as you can see. Right? You can't go from incomplete directly to active. That would be a violation of our state machine contract there. You have to first get your email confirmed by passing through pending confirmation. You can't go from incomplete to grace period, etc. Make sense? Yes. Okay. So, proper. It's an Erlang property testing library. I think someone else is going to talk a bit about generative testing as well later. Proper contains 2 parts. I should also say you can find proper here. There's a generative testing part. Generate data, try it in your function. You write down some sort of invariant to make sure the data is correct. I'm going to talk about the other part of proper, which is about specifically testing state machines, where you model the state machine again, and then you can test the real implementation with a harness that takes it out for a walk and stress tests your implementation and tries to find a set of commands, a set of transitions that should not be allowed, and then prints that and say, dude, the hell are you doing? Right? And what's great about using an actual property testing library than just using Faker, if you're familiar with that in different languages, is that a proper testing library also has something called shrinking, like quick check and proper, which means that it can actually reduce when it find like a counterexample, this set of commands or this set of data, it crashes your stuff, right? It can actually continuously run that again, but mutating this and trying to shrink it down so that you get a minimal example instead of having like this huge blob or whatever. But if you need a huge blob, because that's the problem, that it's like bigger than 1 kilobyte, then you will get that. Yes. Now my favorite part. Demo! Yes. Så gör vi. Okay. Needs to be bigger, right? Maybe this big? Maybe we can do it like this. Maybe even bigger. Big enough? Hopefully. So I've written a user and I've written a user test suite. In this case, I'm using CT as my testing framework. You could you can integrate proper in either EUnit or in CT tests. Since I'm running this big test, I'm doing it as a CT test, but generative testing, like the normal quick check stuff you usually do inside EUnit. I'm gonna talk a bit how the test harness works and how to actually write this as well, doing it a bit more practical. But let's start with the implementation first. First off, I like types, even though I'm in a dynamically typed language. As some of you know. He's laughing over here, by the way. So I've defined, and there's a kutyme. Convention, thank you. To call the name of this module's type as T, because this one will become then user : T, like that. So when you refer to it outside, it looks a bit more nice. This is, it's both a part of proper, it's part of Elixir. I'm using a generic type that's parameterized on the state, and I set the state here. And then I describe the fields that I have available. This is actually a map. As if you know Erlang syntax, you will see that this is a map. And I have, using this walrus, I have defined which fields are mandatory. I've also said that this is a binary, but it's an is86 that's formatted binary. But if you look at down here, the name and email and stuff, they're all just new types, basically. They're all just synonyms. But it's good for documentation. And Dialyzer does not respect this, but another tool could actually enforce nominal typing here. Dialyzer only uses structural typing, so it will resolve all these until it gets to binary. So you can mix stuff. So you can write stuff that should have been violating the type system, but it doesn't, because that's not how Dialyzer actually functions at the lowest level. I defined all of the states as well as all of these atoms. And atoms in the Erlang type system, the Dialyzer type system are kind of special. Those are, the closest thing is like the TypeScript string literal types. They are a type in of itself. So like Dialyzer knows that the difference between incomplete and pending confirmation. It will not know the difference between different binaries or strings, but it will know the difference between these two. And we will come into play later, because this, by parameterizing the type up here on state, that means that we can actually express state conditions at the type level, which means that you get a Dialyzer error if you try to return the wrong state. Kind of cool. New just creates a default one. Some empty binaries. These are basically empty strings for everyone that does not know Erlang syntax. Yes, it looks weird. Yeah, I'm sorry. Use Elixir. You didn't hear that. Undefined, even though it has a special color here, it's just an atom. It's just like a convention that we use undefined to mean the opposite of a defined value. It's not null. Null is unit or bottom. but undefined is the no value, you know, no return. Yeah, some jQuery style accessors. 1 parameter in, you get it. 2 parameters, you set it. Inga konstigheter, as we like to say in Swedish. Here it gets to be more exciting, but I'm going to skip over on just for a tiny second, because then we have the states. So I'm modeling each state as a function of this module, so that you do user colon incomplete, user colon blah, 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 right? And then all of them will take the same parameters in, and usually you expect them to return the same stuff. They won't, which we'll look into later. And you can see like, oh, but if you expect this, then you will get a crash. So the idea here is that you can call each of them in the same way. And this is what on does. On is basically a dispatch. So you can call it with the user object, with some sort of event and some data of that event. And you dispatch the event, just like event listeners in JavaScript or your favorite language, basically. I'm doing here by hand, right? This is you know, kind of quick and dirty. But it works. And it also happens to be tail call optimized, so it doesn't even cost anything, which is nice. Looks at the state, calls the same function. I could have done this dynamically. Like this. But, okay, A, can you read that? If you can, you are writing way too much Erlang. Please come join us. If you don't, it's okay, because that looks bonkers. And also, every single tool is going to get real confused by this. So instead, I'm being explicit and you know, actually doing the work here. Yeah, it's copy-paste code. It's fine. This is better because this means that all tools can follow much easier, which gets you better type information when you run dialyzer. Speaking of which, incomplete. It takes the type T in the state incomplete. It's going to be incomplete a couple of times there. But this is really clear, right? You can't call this function if the state is not incomplete. That would be an error. That's bad. Don't. Right? This means just that there's a map. It can include anything else. Like when you pattern match on a map, it doesn't mean it has to be the empty map. It just has to be a subset of the map. So you are allowed to have extra keys. It makes more sense if you actually match on 1 or 2 keys and you can have more. For example, if you pattern match on state incomplete, but you can also have the name and email, right? But the empty map, you can match like this. This only tells you this is supposed to be of the type map. Classic result type, okay, or error tuples. Tag, error, result, either. You know, Chatban har många namn. In this case, I only accept the sign-up event. If I were to have more events here, I would type them here to be able to tell to the dialyzer, hey, you can call me with these and these events. Again, atoms are special. They can actually get tracked. That's nice. Some reasons. Again, you could have, if you have more reasons, you can do that. Which fields are we allowed to talk about? Stuff like that. This does some pattern matching to check if you are calling this with some sort of empty email or name, and then returns a map with field and that they are missing if they are. And if everything is fine, call the setters, change the state to pending confirmation. Everything is good. Here we also said pending confirmation. So if we run dialyzer right now, it's going to be good. It's going to say, oh yeah, everything is good. But if I try to return another state, say active here, and run dialyzer, dialyzer will be sad. Not it. Nej! Din jävel! It used to be sad. Okay. Maybe if I do foo, what happens then? This is why I love demos, by the way, because something breaks. Okay, this is hilarious. I apparently have been fooling dialyzer too much. That's funny. I did get this error message while I was coding this before, so I guess this code is now too complex, so it gets confused, which is really sad, actually. But it's good. That means that you can't trust dialyzer all the time. Anyway, same thing here, confirm email, active, blah, 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 grace period. Okay, yeah, so the grace period. Here we actually look at the offboard. We add some dates, we do some formatting, and then we check if now it's within the grace period. And here, instead of returning a user, we're returning an atom, which means that this last state returns another type. Okay? Could be good. Hopefully people not get too bored. Okay, let's talk about proper. So proper, you say that you do this behavior, you include this proper thing. It will import a bunch of functions. So if you see a function that I'm calling here that's not part of that I haven't defined here, it's probably because it's imported from proper. It imports for functions for all types and stuff like that. So integer, map, list, that sort of stuff. First, we have the city test stuff. You only need all. You can do the init per suite, init per test case stuff if you need to have setup and teardowns. They are run in a different process, so some stuff does not work the way you expect. For example, if you want to use mech, the mocking library, you can't use those inside init per suite or init per test case super easily. You have to do some extra stuff. This is the test. This is the common test that does run the property testing, right? This is the bridge between them. Then proper itself, or proper statem that I'm using, needs these callbacks. These are commands that we will talk about later, and these are symbolic calls, which we'll also talk about later. I don't have any custom types here, but if I were to have custom types, I could export them here. If they need to be exported, that is. It kind of depends. This is super simple. Like this CT test only have one test to run, right? This test, so it's just all like that. Here we have something interesting. Proper quick check. Call this property, run 100 tests, return a long result, and find stuff. Quick check will actually run this test many times, right? But by the time the proper quick check call itself returns, either it will have found an counterexample or it will have passed, right? So inside here, it's going to run it like 100 times. But once it actually returns, so in this of here, now we're actually done, right? Some translation between quick check and the outer world. If you need to return fail like this for CT to be happy. And why do I do this instead of using CT's property testing bridge that's like built in? Because it does not respect options at all. It doesn't pass along options, which means that you can't change the num test or long result. Do it this way instead. Don't do what CT test thinks you should do, because it does not work. This took some time to figure out. It ended up with my colleague calling the guy who wrote property test, since he happens to know him. Kostis is really nice. Thank you, Kostis. Anyway, here's the actual property test. For all macro from from proper, you're going to see this a lot. For all basically defines a property test in the proper world, like in proper world. This is the property that we want to test. It basically gets matched on this, and then it runs this thing inside a function. So it looks a bit weird, but you could imagine it as if it were written like this. And then you run this begin thing. Of course, since proper needs to run your test many times, not just once, it has to do some wrapping and stuff to make it to work its magic. This is where property state and run commands, again, run the commands in the context of this module. When fail, another macro. If it fails, run the first one. If it works, run the second one. This basically does prints the stuff that happened and say, hey, if it failed, dump some stuff to the log so that they can take a look at it. This can be improved. Array command stuff result okay thing. This basically just gives you now statistics at the end if it did work. You get like how many calls of the different, like percentage, how many calls of the different versions of different functions you were called. We're going to look at the output and you're going to see what I mean. Here we have initial state. This state looks a bit different. User, no user. But we also have the state outside. We have a current day, and we also save the email. In this case, the email one is not used anymore, I don't think, but it doesn't matter. This is the state of the state machine, the testing state machine. And here you can keep a bunch of bookkeeping around, which allows you to test the actual thing, in this case, user, right? But you may want to keep stuff like current day, which is a way for me to track time so that I can fake advancing time. So I keep it outside. I was also doing a lot of experiments with email. That's why we have email. And I also want to keep the state as well on the outside so that I can look on the inside and the outside and verify between them. The big one, command. This is a callback that gets called repeatedly with the model or the initial state here, usually called model. You need to return a property, like a proper property, not an actual command. And this is where things gets real. Yeah, let's just say that. So that's why I use this one of, which is a function imported from proper, which allows me to say I want one of these. It's like a union, a choices type stuff. This one of actually returns a tuple with a bunch of information that the proper engine later on calls. It doesn't actually return one of these. It doesn't do a random call. It returns information about which random stuff it can do, right? And this is what I'm talking about here. It actually returns a property that describes multiple different cases. And this is why you can also use this lovely let. Here I'm saying let days be an integer between 1 and 30 inside this expression. So here, inside this expression, days is actually a number, a real number, not one of those fancy prop types. But let returns a property again, and you can do this recursively, which means that when proper resolves, like wants to actually get a value, it recursively resolves all of these properties, actually calls it with some sort of random seed, blah, 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 puts them all together, and you end up with one of these things that looks like this. This is a good, more easy one to read. Call module confirm good email user. This is what's called a symbolic call. So command up here does not actually run a command. It returns one command that can be run given the current state of your testing module. This gets really complicated really fast, but bear with me. The idea is that proper actually generates many sequences of commands, and during shrinking it actually like modifies the sequence that it have found that failed and starts generating new commands and branches off from that and stuff. And all of that needs to happen without side effects, right? You can't have side effects in here because this is called many times. Way more than 100, by the way. I'm running 100 tests. This gets called thousands of times to generate all those 100 tests. Okay? The net result is that each of these calls is basically module : confirm good email with these parameters. That's what gets called at the end when it actually gets resolved, when it actually gets called, which is nice. I'm using a convention by placing an @ symbol, which is legal in Erlang variables. Little known fact. To mark stuff that's symbolic. So user here is an actual user. But after a while during this command generation, user becomes a symbolic value, which is like var1, which makes no sense because it will get resolved when it runs the sequence. And that means you can't pattern match on user at all. It's an opaque value. That's just the thing. And this is where it gets complicated because you can't. The usual tool that we all love in functional programming, pattern matching, gets taken from you. God damn it! All right? So you have to do other stuff instead. Since I wanted to keep this a bit dry, I added the dispatch event command, which also does some 1.0, which also does some lets with event property, and event property does some more let stuff with some sign up and blah, blah, blah. This is just, like I could have written all the inline inside command here, but it will be really big. The net result is that it will call either this module's advanced day, confirm good email, confirm bad email, or user on, you know, the event dispatch function that we talked about, with one random event. So just push in events. It's fine. The events are depending on which state it's currently in. So we look at the state that the testing module is in to figure out which event we can send. And as long as they kept in sync, it's fine. If they're not, you're going to start calling this stuff with something else and everything breaks down. It's sad. We're going to look at what that looks like later by just commenting out this thing above. It's going to crash. Yes. Here I have an A property. Again, generate some test data. Generate some test data. This is the easier ones. These are also useful if you want to write generative tests using proper. You can write stuff like that. I like this rather than just saying binary. A, because binary is bonkers, or even if you use UTF-8, okay, you get random text, that's fine. But the problem is you can't read that. This is much more readable. So I prefer that because that means that the test case that I'm looking at when I'm trying to debug says john@example.com rather than, you know, a long string of Chinese characters and stuff. I'm not using precondition in this particular instance. I use pattern matching to make sure that I generate commands correctly from the beginning. But each command up there gets filtered through the precondition to make sure that it's actually valid. Since I always return true, it's fine, right? It's always going to be fine. You can do filtering here. If you do that, though, and you're too harsh, proper will give up and say, hey, I couldn't find a valid command sequence because precondition was too sad. So, but if maybe you have a use case where it's much easier to express your constraints in a precondition instead, and that's fine. Here everything is symbolic here. The model has symbolic stuff. Here's symbolic calls, etc. Post condition. Here was where we do the assertions basically. Except we don't do an assertion, we actually just return true or false. But here we want to check the state. And in here you get the state as it was before. You ran the function. The call that you actually ran, and the actual result of that call, the real value. In post condition, there's no symbolic stuff anymore. You can pattern match, it's all good. Everything is happy. Very nice. Yes. So here I'm matching on what state I'm in. I'm matching on calls where, since I know that on has a user, an event, and some stuff, I can see, okay, when I'm in the state incomplete and I sent a sign-up event with these parameters and I got an error back, that is only valid if either name or email was empty. So you can express this here, right? And then you have similar stuff for the different states. You have from friend and completion, blah, blah, blah. I'm going to come back to confirm email and confirm good email, confirm bad email. I can just mention it briefly. It turned out to be really hard to generate random emails and figure out if they were valid or not, like using the let macros. So it's much easier to just define two functions where I define it as a good or a bad. And then I can pattern match here, because this will always be like an atom. It's fine. Even in a symbolic call, it's always going to be an atom. And then I know it's supposed to be good. I know it's supposed to be bad. And that's why I can then check the tag here to make sure it's OK or error. This is much easier to make that happen. So this is like, OK, it would be nice if I just generated an email and checked if it was OK. But I can't do that because I'm in a symbolic world. And that means I need to be able to work with this symbolically. And this comes not here, but when we go to the next callback, which is called next state, where we also work with symbolic values. When we advance the day, that's just an eternal function to be able to advance the day, right? That's just part of the testing harness. It doesn't matter. We don't change the user, so we just return true. And then finally, here we look at the result, where the result is ignore or delete, and then we check if the current day, if it is less than 30. And this is basically to say that unless 30 days has passed since after you have offboarded, you should not delete this user. And then for everything else that I haven't defined, it's fine, right? True. If you want to add a condition, you continuously add on top of this. You add more function clauses here to be able to say more about a specific subset, right? Next state. Okay, so I said that you were calling command repeatedly. You're actually calling command, precondition, and next state repeatedly, because it calls command, then it calls precondition to make sure that it actually is a valid command, and then it calls next state to produce the next state so that it can call command again with the new state, so on and so forth, and that's how it generates more and more calls, right? Great, except everything becomes symbolic now because everything is symbolic. God damn it. Potato, potato. So stuff that comes in here is the model, again, as you all know. The symbolic call is number 3 here, that you recognize. And then we have this parameter here, which actually should be an at here, because it's symbolic. Sometimes it's dynamic or symbolic. It turns out treating it as symbolic, it's fine, and you don't need to care. And never try to use it as an actual dynamic value. It's fine, because otherwise you're going to get a bunch of weirdness. So treat it as symbolic and it's fine. But it can be dynamic because it's also used after the actual call. It also calls it to get the real new state to be able to perform the next call. Stuff inside the call, since we use let, which generates an integer, generates an email, it means that inside the let, I said that it was a real, not a symbolic value, right? It means that these name and email at this point are actual real values, which means we can pattern match on them. We can look at them. We can do a when. And this means that I can say that I'm going to assume that after the call on sign up, where the emails are not empty, I'm going to end up in the state pending confirmation. This is what nested state says here. We actually set it. And then later on, we will verify this. Right? So this is how we can we take a peek inside the symbolic call to figure out our next state, what it should be in. And we could also have looked inside the models of the previous state to be able to understand this. And by the previous state, I mean the previous state of the testing module. Test state. Then they have this lovely helper function, symbolic update user from result. Yeah. There's a bunch of more stuff, similar stuff. We're not going to talk about that too much. I'm just going to show you symbolic update from user of result. Result, again, is a symbolic value, which means that result is probably a var something. Says nothing. So how do we do this? Well, if we return a symbolic call instead, at the time when result is not a symbolic value anymore, proper will call whatever we specify here with a real value. So what we do is we just say call module some function with the stuff. Lovely, and that's below. Here, it's an actual value. Every time you need to handle something, just use a symbolic trampoline like this. It's the easiest way. Here you can pattern match to a heart content. No problemo, right? And then we have a bunch of print commands, but that's just for debugging. That's not super important. Days from now here, it takes the days, it does some stuff. Again, days from now are also used in a symbolic call somewhere. So that's why we need them separately as well. Yeah. So the model, I'm going to change the user field to this symbolic call. Is what happens here. So that's why model's user is going to be turned into this call of call of call of var of call of var. It's going to look like this, huge. But it's fine because it gets resolved at some point. Okay. Hooray! My test suite passed. Yay! Am I starting Firefox? Yes, I'm starting Firefox. Oj, här var det lite litet. Okay, so in the HTML you get the dots vertically, because of course you do. Here's what it looks like when the test tube passes. You get to see how much percentage of time it's spent on the user on function, on the advanced day, confirm or confirm, good or bad email, like this. Of course, you might have more function, like I'm abusing user on, right? That's why over half of this time is spent there. You can have weighted instead of just a union that I choose, like the one of. You can actually weight it instead. You can do sorts of tweaks. You can even do targeted and have a user function that you maximize and all sorts of stuff if you really want to do. But this is, here you can see. Ran 100 tests, everything is good. Okay, let's try to break stuff and see what happens. So if we start to return false in, one of these somewhere, every time you call false advanced day, you're gonna get a bad. You get the failure here. Oh, latest test results. Failed after 20 tests. Then it failed. And this is a really long one, so you're not going to need to look at that, but you can look at the... So this is what actually gets printed out by CT, and it's just horrifying. This is the stuff that got printed in the when failed, right? Here you have set var call user on, set var call user on, blah, blah, blah. And you can get this call user result from our module. You get this really deep stuff. But you can read that. You can see, okay, here user call on, user on, confirm good email, right? Okay, and then user on again, Set var advanced day, right? Okay, user on. If you squint your eyes, you can see some stuff. The history tells you what the state was and what the actual return value was from the different calls. The actual state is the last state that it was in. And then you have the actual result from the property quick check, which is in this case post condition false. However, then it did some shrinking. Shrink it 5 times, and you get this instead. Advanced day failed. Bam. In my case, I have made a function that makes it so it actually tries to print it out in Erlang syntax instead of this obnoxious stuff. So you can see that as well. Okay. If you try to, as I said before, if you confirm good bad email, for example. Remove that. I should get a failure. Bam! Again, go in here. Okay. Failed after 9 tests. And now you get an exception function clause, pending confirmation. So you try to call pending confirmation. It probably tried to use an event that's not valid in the pending confirmation state in this case. And it tried to do offboard, right? You can't offboard while in pending confirmation. That's not allowed. So, and then you again like runs, and then it can actually try to shrink it. It didn't find any better. Here again, you can write some code if you want to do stuff like this to try to figure it out. Unfortunately, all binaries become this junk instead of, you know, email. This is probably maybe this is Jane at example.com. Kind of looks like. Yeah, anyway. And 97, that's A, right? I think. Anyway, so stuff like this. This is how it looks like. Please use it. Questions? What? Are you in shock or shock and or? Shock. Do we have any questions from the audience online?
No. No questions from the audience online. They are in shock. Joking. I have one question to you, Max.
Yes.
You said you're gonna show how to teach the product owners how to use state machines and how you can teach them. So elaborate on that. Because if I show a product owner this, it's
no.
not that they're gonna.
When we introduced the concept of state machines, or when I introduced the concept to my product owner, I said, I basically did a lifetime argument, right? You have a user, or in our case, a company. It's signing on, it's there, then it's trying to offboard. We have a period of 45 days at Kivra where you can change your mind and where you have time to download all your content, blah, 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 before we wipe everything. We have that grace period and stuff. So it's kind of easy. And what I said is like, please define the state that you believe our product is in. Like describe the life cycle and draw lines. And you can do that on paper or you can do that in Google Drawing or whatever. And they did it mostly on the whiteboard. And then they did some Google Drawing, I think.
And from that, you could derive down to what you're going to code or implement.
Yeah, so like once they've done that, me and my colleague, we were then talking with them and be like, okay, but here's what does this mean? Okay, but do we need this arrow here? Okay, what does this mean? And then he figured out that we needed another state that we didn't even have. And so it's like just drawings. And then, right, okay, when I show stuff like this to my product owner, he's just going to be like, wow. When I show this to my colleagues, most of us are going to be like, oh. So it's okay. But drawing, like actually draw and lines and specify the events, the business event, the domain events that says that this and this happens. Super useful. Of course, at work, I have written an engine that uses behaviors and modules that's also integrated with our database layer, and and you can run. It uses a fixed point instead of this manual recursion. So you return the next event, and it continuously run the event machine until it arrives at a steady state, and then it aborts. It also has logic to detect recursion, and has logic to detect if you have infinite recursion due to other problems. So it's like a bunch of and then it has a bunch of logging and instrumentations. So the actual implementation of the state machine engine that I've written is way more complicated than this. But this is also fine, right? One thing that I didn't really touch upon here is that this is pure. All of the stuff that I did was pure. I just changed data. Something would have pulled it up from the database, and then you could put it down. As long as the stuff here in the middle is pure, or you return a list of side effects, aka send this email, so that you can run the state machine without actually doing a side effect, you're golden. Without that, you can't do shrinking. Because if the shrinking backs up and replays and does a bunch of stuff, right? So that could be really spännande.
Exciting.
Exciting. Yeah, so and we have a lot of in order to know which state we're going to, we have to do some API calls, external APIs, which means that we do not do any shrinking on our property space in our property tests. We can't do that because of...
I have one question.
Yes.
Does next state get called twice? 2 times?
Hundreds of times.
Hundreds of times, yes.
Thousands. As many times as command. No, twice as many as command. One per symbolic call, and one during command generation, and one per dynamic call between each evaluation of the calls.
Cool.
Yes.
Thank you very much, Max. Thank you very much.
Ja, just det. Jag glömde bort. Here's the questions.
Yes, you passed the questions.
Yes. Avsluta. Så.
Thank you.
Thank you.
Now, Jane, can we keep this?
Maybe.
He also has a Mac.
Also has-
Yes.
And here's
It's very
another Mac.
Oh my god. Welcome, James.
Thank you.
This one.
See if it works.
Yeah. Fire up the screens. Downloading your computer. Hacking your bank ID. Yeah, we got it. Give him the screen now.
Let me just get into presentation mode.
Yeah, sure. So, welcome, James.
Thank you very much. Let's move this over
Your
here.
presentation.
Screen. Great. Hello, everybody. Thank you for inviting me back. It's an honor and a pleasure to be here again. Today, I'm going to be talking about banking on Clojure, which is what we do at the company I work at, Griffin. A little bit about me. I'm VP of Engineering at Griffin. Been there since March this year, 2021. And you may have heard of some of these other companies I've worked for before. I went to the dark side of management quite early in my career, but I did start as a developer. I'll be showing a bit less code than Max did in his presentation, but some. So we'll get to that. And I'm going to be talking about 2 things. Building a bank with Clojure, so why we picked Clojure, how we're building with Clojure, and some other technologies, and why that's a good match for banking and finance. And then I'm going to stick my neck out and talk about a simple code manifesto. I think it's been a bit too long in our industry before someone's come out with a manifesto and said this is how you should do things. So I'm going to give that a go, and I await the flames in the YouTube comments. So let's dive in. Building a bank with Clojure at Griffin. So Griffin, we're building a new kind of bank. It's not a bank that you would use yourself. It's not a commercial bank. It's a bank for other companies to build their financial products on top of. And the way we're thinking about that is it's a bit like AWS for banking. So AWS, what they've nailed is this idea about having industrial strength compute data centers behind an API. And our idea is industrial strength financial solutions also behind an API. So what's the business problem? Let's start with some context and some marketing slides, and then I promise we will get to code. I'll whiz through this. So we have this hypothesis that modern consumers are demanding contextual financial services at their fingertips, i.e. in the apps that they're using. If you're anything like me, when you order a taxi or you're ordering food to be delivered, if it's locked down, if you want to transfer money to your friends, split a bill, do loans, or manage your savings, the problem is for the companies that build those apps and those experiences. And the problem is that the whole domain is so complicated and that there are so many different moving parts that you need to understand and work with that the lead times for building it can be very long. You have to understand this really complicated domain. There's a load of regulation in that domain, especially now after what happened in 2008, 2009. So there's also risk involved from a business perspective. And the APIs for all of these various puzzle pieces tend to be quite old. You know, they're legacy, it's an annoying thing, and you're integrating all over the place. So our idea is to make that much simpler and faster, to get rid of that time to market problem that they have, that complexity problem, which sort of leaks out into the products that they give to their customers. So our idea is to solve that time to market problem by offering a single unified platform that's built on top of an actual bank, and then offering that to the types of companies that are building these financial services. And we call that the bank you can build on. And by being a bank underneath, so not just being an API, so not just a technology company, actually having a UK banking license, the value there is being able to offer products that they can't get anywhere else, especially if you're a fintech. There's this issue where if you're a fintech, because you can have a new business model or you have a new market that you're entering, these incumbent banks don't have enough understanding of what's going on there to actually even say, yeah, we're going to give you a bank account. They're blind to the kind of customers that you're attracting and the kind of model that you have. We solve that problem by understanding those nested customers. So this gets a little bit inception, so our customers have customers, so our customers' customers, and those are nested customers, as we call them. So they can be individuals or a business, and then so they're in purple on this diagram. So our customers are in blue, they're our direct customers, and we're in yellow, and we offer all of these different financial solutions via the API and via a UI if they need that too, and we build on top of third-party partners in the wider sort of financial area, things like regulation technology and clearing banks and doing payment schemes and payment rails and doing all of that sort of complexity. So we amalgamate all of that, put it behind a really clean API, expose it to our direct customers, and then we know about the nested customers. And the secret there is because our direct customers on board using our onboarding technology, but so do the nested customers. So in this example with Uber would be our direct customer, and the drivers for Uber, they would be the nested customer, but they would onboard with the same onboarding technology and with our onboarding and compliance experts. And then we know about those drivers and we know what kind of money laundering and other kinds of risk that they might have. And that's where we can offer better prices, and then the API is cleaner, so faster to get going. So what does the API look like? So here's kind of some code, not really, but so creating a bank account, if we're curling at the terminal, you pass in a little bit of JSON. We do some magic on the back end, and we return some JSON, so it's JSON over HTTP. and then you have a bank account. In this case, it's a deposit client money type of account. And then you're in a restaurant and you want to pay for your meal. So again, you send some JSON with your terminal, you pay £35 here for dinner, and it gets accepted. Kind of cool, right, to be able to pay for your dinner with your laptop. Obviously, in the real world, that's not how it's going to work. This is just an example so you get an idea about what the API looks like. In the real world, our direct customers would build their solutions on top of these endpoints, and as a user, you'd be doing it in the app. Not quite as cool as with the laptop and the terminal, but still. So what about the architecture then for doing that? Here's an enterprise architect kind of box and arrows diagram. So Fluffy Cloud for the direct customer, they make a request to our API. It does all the classic API routing, middleware, authentication, authorization to make sure that the person has the rights to make that request. And then where our architecture is different, and maybe what's the most interesting thing to point out about this, is Kafka in the middle. I've drawn it with the database icon. It's not really a database. Kafka is an event log. But in our system, it almost acts as the database. So what I mean there is we've kind of flipped the script when it comes to where the source of truth is. In most systems, the source of truth is your database, your Oracle or whatever, NoSQL or whatever database you're using. But for us, the source of truth is this immutable event log in Kafka. And then we've come up with this new concept we call procs. I'll explain those later, but basically they're a log processor. So they're a little unit of code that reads an event or a message from Kafka, does some processing, puts more events or messages back in Kafka in these different topics. And that's the basic architecture at a very high level. And as you can see by the logos, it's all Clojure. So Clojure script on the front end, the API is written in Clojure, all the Kafka modifications Clojure, and the proc system Clojure with transducers. We'll get to that in a bit. So why Kafka? So it's an immutable timeline. That's a really good match for our domain because it's banking, and banking is built on the concept of immutable ledgers. We'll get to that in a bit in the future. And whenever you can make your system look more like the domain, you reduce this code model gap, and it's much simpler code, much faster. And it's really good for things like audit trails and everything that these regulators are really hot on. It's a perfect match. It's a single source of truth. Like I said, it's like our database. It's the one place that we can go to sort of keep track of and have a consistent view of what's happened in the system. So there's no update in place. There's no overwriting data when it gets out of date or when it's updated. It's a single source of truth that we can then reconstruct. Let's say something goes disastrously wrong. We can actually replay all the events and rebuild the state in the individual log processors so that we get back to a known state. Kafka is really good with horizontal scalability. It has these topics and partitions built in. That's good when you're a bank and you're trying to grow and you want to have millions of customers and transaction volumes that are really high. So it's going to grow with us. We can just add scalability, and it helps with decoupling. I'll talk more about this later about how the architecture works, but it helps with decoupling because it enables the different bits of the system to talk via the event log rather than talking directly to each other and becoming entangled. Okay, so let's quickly do an example where we're making a deposit in the bank. So the customer makes a request to the API, make deposit. It gets put on a Kafka topic called API requests. It gets picked up by one of these log processors that's listening on that topic. And it's like, oh, I know how to deal with that, and I'm going to orchestrate what happens in the system. It will call other log processors or procs, in this case, bank accounts and ledger transactions. And those will do different things. There might be side effects and other things going on there. And eventually, a message will get all the way back up to the customer. Yes, that deposit has been made. So let's have a look at a little bit of code. So procs are declarative, I guess you could say, in terms of it's a data structure and a macro that we've written that sort of takes that data structure, processes it, and turns it into that proc representation. And the key thing to spot here is that it has an ID, it has a Kafka topic that it's listening to and putting messages back to, in this case HTTP requests, and then there's a map from message received to messages sent, which is a set. In this case, each one only has a single message that it receives and sends, but it could send many messages to other procs. So when a make deposit message is received, then it's going to send a fetch account out to somewhere else. They're going to do some account calculations. So it doesn't know about that. All it's doing is sending and receiving messages, keeping it really nicely isolated. And then the actual implementation is done with a transducer. So make deposit X form. I'll show you what that looks like. I'm not going to go too much into transducers. There are other videos on YouTube. If you don't know what those are, it takes a bit too long to explain. But basically, it's a way of abstracting away the inputs and the outputs for a reducing function so that you don't really care about them. And in this case, all it's doing is dispatching on the type of the message and then handing off the actual work to these other functions. So handle make deposit, handle account fetched. And the good thing about making it a transducer is it really helps with testing because it's so agnostic to the kind of sequence of messages that are coming in. It doesn't care. It doesn't know if it's connected to Kafka or to something much simpler when we're running our automated testing, which is really nice. And because all of our messages are spec'd, they all use Clojure spec to define the shape of the data, then we can do what Max was talking about earlier, which is do lots of generative testing, even at this quite high level in the architecture, which is really powerful. Okay, so going back, so we go all the way down through all of those. So I showed you the deposits proc code. We didn't see the bank accounts or ledger transactions, but it looks similar. They just care about different messages and they do different processing, obviously, and they know about their bit of the domain. So it's a way of sort of splitting out into these building blocks that are domain aware. They know about their bit of the domain and that bit only. They talk to each other with Kafka. We have this event log that keeps track of everything that's happened in the system. Makes sense, right, for a bank. So that's the basic architecture. So why did we go with procs? They're this really nice building block level abstraction. They kind of take a functional idea, you know, this idea of having something that's clean that doesn't know about what it's taking in, but processes it and spits it out. And they're very composable. And yeah, and it's just a nice level to sort of zoom out and have something that's functional, but at that system level. They're horizontally scalable. If you imagine a conveyor belt with all of these messages coming along, you can just, and the proc is a worker sort of standing there waiting to recognize the message. Oh, I know what that is. And then putting another message back for someone else to read. You can just increase the number of workers that are standing by the conveyor belt. State isolation, because this single source of truth is Kafka, it means that we can implement the state for each of these procs in any way that we want. Maybe there's a proc that needs to do a lot of complex queries. Then it might need a particular kind of database. Others might need huge performance. Then you do a key value pair with blistering speed. So it gives you a lot of flexibility. Maybe they don't need to store anything at all. So they're completely isolated from each other. And I mentioned testability because of that, the wrapping, because of the way you can spec the messages. They're highly testable both from a unit sort of scenario perspective, but also a generative testing perspective. We'll get a bit to that later. Okay, so that's kind of the how and the why of how we built a bank with Clojure, or our building. Now I want to sort of stick my neck out and give you a manifesto of some claims, some insights about coding that we've built up over the years. I guess I should put my name on this more than Griffin's in case people get angry about some of this stuff. But so let's get into this manifesto then. So there are 8 points I'm going to go through. So I'm going to claim that code should have a high signal to noise ratio. What I mean by that is that the intent of the code should be really clear, and there shouldn't be a lot of extraneous details that sort of water down that conciseness and that clarity. I think far too much code out there does not have a high signal to noise ratio. I don't think that data and functions should be entangled. The object-oriented fans out there might be screaming at the screen already, but I think pure functions and literal data is really important to keep those separate, because then it's easy to understand each one in isolation, and they're doing their own thing really well, and you're not trying to tangle them together and make a real mess. Data structures should be literal, and I mean literal in two senses of the word, I guess here. I mean literal as in they should be readable, but also literal as in like the data literal sense that it should be a part of your language where it's pulled up to a first-class citizen position. And why that's so good is how it enables you to read, understand, and communicate about it. We'll get to that later. I argue that code should be grown in a REPL. So REPL read eval print loop. Some languages have this, some don't. The difference when you've got a language that has a REPL and that doesn't is really like night and day. It's one of those things where once you've tried it, you don't want to go back. Maybe people are already feeling there's a theme to these, but we'll get to that. Systems should be built on an immutable timeline. I think for far too long, we've taken liberties with how reality works and how we modeled that in our systems. And we've used update in place ideas. And yeah, it made sense in the 70s when we had really small computers and hard drives cost the earth. Now it doesn't make sense. Let's model reality a bit more like it actually is. Side effects should be isolated. What I mean by this is that because pure functions are such an awesome way to write code, and most of our code, if possible, should be pure, all our code can't be pure. Then we're doing nothing at all. So whenever we have inputs and outputs, of course, there are going to be side effects. But if we can keep that off to the side, keep them protected, then the majority of our system is testable, it's understandable, and those bits that get messy and have to deal with real world things are off to the side. Really useful. Yeah, this might get the Haskell types a bit upset, but I'm going to claim that maps and schemas are more flexible than types. Notice the word flexible. That's important. What I mean with this is that, well, I don't know the kind of companies that you've worked in, but for me, our understanding of the domain is never fixed in place, and it tends to change rapidly. Requirements change. Things are changing all the time. It's an extremely dynamic environment. And it worries me that so many of our languages focus on fixing that understanding that we have right now, right at the low level in the programming language, rather than using the power of an opt-in ability of maps and schemas. We'll talk more about that later too. And then a final claim, generative tests are more powerful than unit tests. Now, the important thing to say here is not that that doesn't mean that you shouldn't do unit tests. We'll get to that later. But just I think too many teams, too many developers don't understand the power of generative tests, and Max showed it beautifully earlier. Okay, so some of you may have noticed the theme there, and we picked Clojure because we think it does a really good job on all of those. That's not to say that there aren't other languages that can tick a lot of those boxes too. There definitely are. But let's go through and have a look at how Clojure does all of these really well. There's this really nice metaphor that Reginald Braithwaite came up with on a blog post of his from quite a few years ago, where he talked about signal to noise, and he talked about these three highlighter markers. So the idea is this: imagine you have a red highlighter, and every time you're reading a bit of code and you don't understand what a line does, you mark it in red. If you understand what it does, but it's not doing, it's accidental complexity, that's the noise in the code, you highlight it in orange. And if it's a pure, simple, declarative way of describing the problem or the solution of your domain, you highlight it in green. So obviously you don't want any red, you don't want to see that because you want to understand all the code. You want as little orange as possible, although it is necessary, more so in some languages than others, and you want as much green as possible. So let's do an example of this. So this is some Java code. It's taken out of the Apache Commons library. It's a function that checks if a string is blank. And I would argue, maybe you could argue slightly differently about how much of this is green and how much is orange. There's no red, that's good, but there's a lot of fluff in here that's not really telling us about the domain problem it's solving. The core idea is basically, are all of these characters white space? But because there's for loops and there's ifs and null checks, and yeah, there's a lot of places that bugs can get in. If we would rewrite that in a more functional Java way, we've gotten rid of a lot of that orange code, and we're left basically with what I would argue is pretty green code. You could argue there's a bit too much boilerplate in Java, and maybe you wouldn't classify all of this as green, but I'm being kind today to Java, so we're giving it green. But here, we take a string, get all the chars, the characters out of it, we check that they all match, that each character is a white space. It's pretty clean. Here's the Clojure version of the same thing. And you'll notice it's even more concise, which is good. Concise helps with signal to noise. and we're checking is every character whitespace in the string, is almost exactly how you would phrase it in English. And this is quite a low-level function. But when your low-level functions can have this kind of clarity and this kind of signal to noise, is a really good sign that when you get up to the more domain orchestration functions that describe your domain, that you're going to be able to keep those with a high signal to noise too. Great. Data and functions shouldn't be entangled. So what I mean with that is basically we should separate data from behavior. And the reason is, I talked a bit about this before, but pure functions are easier to deal with and think about in isolation. Pure data and tangling them together, like in a class, is probably a pretty big mistake. So let's not do that. Riak has a great quote about this. When you combine two pieces of data, you just get data. When you combine two machines, you get trouble. And we don't want trouble, so again, we won't do that. Data structure should be literal. So we should pull them up. They should be first-class citizens. I think Jason has shown how important this is and how much power that gives you, because it becomes easier to construct, read, understand, communicate, and test. So don't hide your data structures or your data behind constructors, behind getters, behind setters, behind code. Bring it up so you can see the data and communicate about it with yourself and with others. Code should be grown in a REPL. Instant feedback. So I think the faster that your feedback loops are, the better the final result is going to be, because we're constantly testing hypotheses when we're programming. We have an idea, we think we've understood it, we've understood the domain, and we start typing and getting the compiler to see, have we understood it? And the quicker that we can get that feedback loop, the better. When you don't have a REPL, the fastest that I've basically seen is like the test red-green refactor loop. You write a little unit test, you run it against the code you've just written. It's okay, but it's not as instant as a REPL. And it enables, when you have that instant feedback, it enables you to iterate. You start shaping your code in a completely different way. It feels like you're working with it like clay rather than, I don't know, what's the opposite of that? Working with it like typing it at a distance or something. And it lets you play with your code. That's a fun way to work. And when you're having fun, you're going to get into it more, you're going to spend more time, you're going to keep trying and shape a more beautiful and simple and more declarative version of the thing you're working on. And I think there's a lot of value in that. Already talked quite a lot about immutable timelines, so I'm going to try and go pretty fast on this one, but Clojure has a really nice model of time. Riak talked about it in his talk, Are We There Yet? So if you want to find out more about it, that's a great one to watch. But the basics of it is that you have this immutable timeline where you have states that are immutable values, and the functions read and write to those states, and it gives you this solid foundation to build your systems on. No one can come in, fiddle with things without you knowing about it, and then you're, whoa, what happened there? These are values, they're facts that change over time. Just like in real life, if my hair was blonde yesterday and now it's brown and grey, those are two facts about reality, but you wouldn't update the fact that I was blonde yesterday now with brown and grey. You would want to know that yesterday that was true, today this is true. And a lot of systems are modeled best that way. And especially the kind of system we're building, I don't know if you know anything about accounting or banking, but historically you have this kind of double entry bookkeeping, you have these ledgers, and if you made a mistake here, you would not go in with Tipex. Well, they didn't have Tipex back when this book was, but you wouldn't cross it out and update. You would put an entry in the ledger that said, undo that one, and then redo it with the correct amount. And that way you always know exactly all of the things, the facts that have happened. So when you have a language that thinks that way, like Clojure, and you have Kafka that thinks that way with its timeline, it's a really great match for our domain. Side effects should be contained. I talked about this before as well. Pure in the core and side effects at the edge. And this is mainly about testability and understandability. The more we can contain the problematic parts, the real world, not this is pure and nice and easy to test and easy to write generative tests for, the easier it is to explain our system to others, to understand it, and to test it. Okay, maps and schemas are more flexible than types. We talked about this. Domain understanding changes rapidly. Types cement our current understanding, whereas maps are dynamic and schemas give opt-in correctness. What I mean by that is you can be dynamic everywhere if you don't need that confidence that schemas give you, or you can just say right at the edge here where we're communicating with the third-party system, okay, there we need to know that what they're sending us is the right shape. Here where we're talking with something internally where it can't fail, or here where we want to do generative testing. So you opt in and do the schema work only where it's needed. Whereas most type systems I know about aren't opt-in, they kind of spread throughout the entire system. So this gives a lot of flexibility and sort of gives you the level of correctness and confidence that you want to sign up for. Systems are dynamic and data-driven. It might be a nice idea to use a language that's also dynamic and data-driven. Okay, generative tests are more powerful than unit tests. Max already gave a great talk about this, but for people that are only seeing this one, I'm going to start with an analogy. Maybe you've never heard of generative tests before. If you think of a generative test like a machine that can produce different shapes of pasta, and the pasta is a different shape of data, basically what you're doing, you imagine you have a nozzle and you put the pasta through and it comes out in all these different shapes. What you're doing is saying, for this function, I want to generate random shapes of pasta of all these different colors, shapes, and sizes, and make sure that when I give it to this function, what comes out on the other side matches this set of properties that I'm going to describe about the pasta that comes out the other side. Okay, enough pasta. Let's look at some actual code. So this is how you do generative testing in Clojure. So you define a spec. This one's called money arithmetic. It runs 100 tests, and it randomly generates a specific amount of money. So in Griffin, we've defined our own sort of money entity that has it has like a currency, and it has an amount that's a big integer or a big integer or a big decimal, I can't remember. But so it has some representation of money, and we need to double check that arithmetic still works, even though we're not just using a basic int type. So this is the generator, and then we have a property that says for all of those random amounts that we generate, that it should be 0 when we add that amount to the minus of that amount. Oops, let's go back. And we check that for all of these, that holds true. And if any of these would fail, if we'd made a mistake in the implementation of money, it would do that shrinking that Max also showed so beautifully, where it would say it's exactly this version of that fails. And why is this good? Why is this powerful? It's because we don't need to think about all of those corner cases. We can just think about describing programmatically, here's the shape of our data, here's how we expect this function to work, make sure that those two line up, and we let we have these super powerful CPUs, we can let that churn through, create thousands of different test cases, and make sure that that's correct. And when you have to describe the function that way, it also causes you to stop and think a little bit about how does this actually work. Now, I said before, I'm not saying instead of unit tests. I still think there's a huge amount of value in the sort of given when then scenarios that you can write with unit tests that document your code at a slightly different level than this. This is slightly harder to understand, and given this input, expect that output. But there are some cases where this is exactly the right way to do it. And let me give you an example where this worked for us at Griffin. This is an amount of money that's 10 quadrillion pounds, I believe that is. So it goes billion, trillion, quadrillion. So that's 10 quadrillion. And we were integrating with some third-party payment platform. They had an ISO specification for the kind of messages that you were sending them. It was XML, I think. And there was a schema that sort of checked that your XML was correctly formatted. And we wrote some generative tests that took these amounts, these payments that we were generating in Eden on the Clojure side, and made sure that they matched the schema. And anyway, after a while, the test failed, and then it shrank the failing counterexample case down to this number, 10 quadrillion, and said it's failing with exactly this. And it turned out to be a number of digits problem. In this ISO 20022, you can't send more than, I think it's 18 digits. Yeah, it's an 18-digit limit, and this, with the pence, is a 19-digit number. So it was the very first case that failed. And I'm not sure, I mean, of course, if you pour through the spec and, you know, of course you could find that scenario yourself, but the generative test found it and the shrinking pointed to exactly the problem. So that's quite a nice example for showing the power of generative testing. Okay, so let's whiz through these 8 one more time. So code should have a high signal to noise ratio. Data and functions shouldn't be entangled. Data structures should be literal. Code should be grown in a REPL. Systems should be built on an immutable timeline. Side effects should be isolated. Maps and schemas are more flexible than types. Generative tests are more powerful than unit tests. So, when do I think we should use this? Well, one place I sort of mentally use this is whenever I'm on Hacker News and somebody posts a new programming language. And what I'm thinking in my mind is, okay, let's check it out, see if it's good. Is it going to solve these things better than the tools we currently have? And you'll be amazed at how many times I get stuck on one. It doesn't even get past one, right? And sometimes it's ticking 4 or 5 of these, and I think, wow, that's a really nice language. But I think if we're going to move forward, I think we need to try and make languages that tick way more of these, and we need to build our systems with languages that tick more of these. And it's to do with the evil that is complexity. I called this the simple code manifesto. I think all of these are connected to making our code a more accurate reflection of what we're building, the domain, and to get rid of that accidental complexity that we seem to love as engineers. You know, we love building these huge ROM systems, to map between our relational databases and our code, and it's nothing to do with the problem we're solving. It's not part of the domain. We write functions that are huge and have all of that orange and sometimes red. Do you remember the highlighters code? We shouldn't be doing that. We should try and condense the code we're writing to just describe what we're doing, because then we're going to be nicer to each other, and we're going to sleep better. And if we have generative tests, our stress levels are going to be lower because our confidence is higher that what we've built is correct, and it's just going to be a better world with rainbows and rabbits. No unicorns? Maybe unicorns too. Maybe they fart the rainbows. So that was it, simple code manifesto. Yeah, we talked about building the bank with Clojure, talked about how we did that, all of the marketing slides, showed you some code, and that was it. Thank you so much for listening.
Very much. Please stay.
Stay, yeah.
Yeah. There's no questions here in the chat yet. However, how big will your Kafka cluster grow? As I assume you will keep your things forever and ever, so that the auditors can check your audit trail. Yes, that's a very good question, and I guess it would depend on how many customers we get and how big we get. Yeah. Depending on that, it could be orders of magnitude difference in size. I wonder if there's also a way that we could have a sort of live version of it that doesn't go back forever, and then sort of have an off-site or some other disconnected way that we could still recover if we needed to, but that we wouldn't have all the time. We haven't have to solve that problem just yet. One more question. Because you're using Kafka between your API and your procs, how does the customer or UI receive the message? Is it subscription-based? Kafka between the UI and the procs. So there's a part of the API that listens to a certain Kafka topic, and sort of picks them up and like, oh, that's a message that I care about to send back to the customers. So for the customers, it's completely transparent that we're using Kafka or not. Yeah. The API protects against that. So for them, they don't know. Yeah. Any more question here in the room? No. Everyone here is a Clojure fan, so. Yes, then. Not everyone. We're getting raised eyebrows from Max. Yeah, okay, sorry. Sending messages, you said? Yeah.
It's more like a difference between what Max shown and what you shown. So the 3 lines you had there, is that all you need for generative tests, or?
That's a very simple test, though. That was a bit of a basic example, so it wasn't comparable to the kind of complexity that Max was showing.
Well, because I'm trying to, get used to the idea of trying this language someday. So, that's it.
So to flesh out my answer a bit, that with the real world tests that we have for real data, where there's some complexity to that bit of the domain, the tests can grow, and I didn't show those, but they still are pretty clean, and it's still Clojure, so it's still got that declarative simplicity to it.
Yes.
Perfect. Thank you. Thank you, everyone.
Thank you very much again, James. Now we welcome on stage Emil. Yeah. Welcome up, Emil. We'll plug in your laptop and hope for the best.
Like James, I'll say thank you for inviting me back a
Yeah.
second time.
Very nice having you here.
We'll see if
If it
you'll
fires up, then
consider inviting me back a third time
Yeah.
after this one. Where
Oh, the screen is firing up.
let's see.
Then welcome Emil.
Now I need to get my window. Where's my mouse pointer? There it is. Here we go.
Welcome.
Oh, that's the wrong. There we go. So it's that time of year. I'm going to tell a very old story with some slight alterations. Edgar Scrooge heard a light knock on the office of his window. He made a show of ignoring it by tapping his old IBM Model M keyboard with renewed intensity, focusing intently on the screen. He threw a quick glance at the window ahead of him, like a mirror in the dark December night, and caught a glimpse of his nephew's reflection. The door opened softly. "Happy holidays, Uncle." "Happy holidays for you, maybe. I'm trying to deliver a project on time, and at this rate, there won't be a holiday," he replied gruffly, his hard features lit only by the Jira chart in front of him. "That's not a very encouraging burn-down chart you've got there. This awful team of mine wouldn't know quality if it hit them in the face. Our issue tracker is as long as the naughty list of goddamn Santa Claus. I'm actually stopping by to invite you to a functional programming meetup tomorrow. Maybe you'll pick up some new ideas that could help." Scrooge pushed his chair out from the desk and spun around. "You think I could learn something from some hipster language that would help with this?" He scoffed. "We're too busy creating value here. We spent half a sprint this year upgrading to Java 8 for no good reason. And I'm certainly not making any more changes until Oracle ends long-term support." His nephew looked mildly nauseous when he spoke the O word. "But Uncle," he protested, "you don't need to change language to improve things. There are lots of good ideas that can be adopted in any language. I've been at this for 30 years, and I've certainly never seen anything useful come out of Camel or Haspel or Lisp or whatever all those silly languages are called. Now leave me alone. I need to fix this null pointer exception." His nephew sighed audibly and turned around. "Well, let me know if you change your mind." Scrooge snorted angrily and turned back at his computer. but was unable to focus. Eventually he gave up, decided to call it a day. He left the office and walked home with heavy snowflakes dancing all around him. The sky, the color of an old television, turned to a dead channel. He was wet and cold, covered in snow when he got home and walked across the yard to his apartment building. As he climbed the stairs while untangling his scarf, a sense of dread came over him. Something was off. Reaching his floor, he found the apartment door unlocked. He hesitated only for a second before entering, and then froze in his tracks as he caught sight of the ghost of Marley. Actually, it wasn't a ghost. That was just the water vapor on his glasses playing a trick on him. Marley, however, was wearing a three-piece suit, which was almost even more scary. "Who are you?" he demanded. "I'm Marley, your former friend and teammate. I remember you and how you left for another job without warning. It's been 5 years and I haven't heard a word from you. We were inseparable for decades and you just left me. The truth is that I didn't leave. I was fired. Someone had to take the fall for all our failed deliverables. And I sacrificed myself. For years I wandered restlessly, unable to find another developer job. Finally, I had to do the unthinkable. I became... Don't say it, Scrooge begged him. I became a manager. Scrooge gasped and found himself involuntarily backing away. My fate may yet become yours. Progress is inevitable. No developer is immune to the fact that best practices change. You have lost your former passion for a craft and stagnated like I did. I'm not abandoning everything and rewriting it in Node.js. Progress isn't about fashion and hype. It's about slowly adopting incremental improvements. To save you from my fate, I've arranged for you to be visited by 3 developers. One will remind you what went wrong in the past. Another will show you what's going wrong now. And a third will give you a taste of what will go wrong in the future. Scrooge entered his home office and found a tall, emaciated man sitting on a chair next to his desk. Weirdly, he had a bowl cut and was wearing a Spice Girls t-shirt. Tell me about the first desktop application he wrote. The man didn't bother to introduce himself. Scrooge figured that he ought to be upset about finding another stranger in his apartment, but unsettled as he was by Marley's dark revelation, decided to play along. It was a drawing program, written in C. Let me show you. He sat down at his computer and started clicking through ancient backup folders, nested several levels deep. How did that go for you? It was a lot of fun to build. It was an incredibly productive few weeks once I got started, and I was very proud of it. It sold a bit initially, but eventually the maintenance became too taxing, and I gave up on it. Why was that? Scrooge found the source code and opened up a file, cbrush.age. I think that was largely why. The entire program state was global, and it was modified from all over. Invariants broke all the time, issues got almost impossible to track down, and so forth. I should have known better. The man in the Spice Girls t-shirt nodded thoughtfully. You weren't in any way unique in that back then. A lot of other programs from that era were written in much the same way. Wolfenstein, Vim, Putty, to name some examples. I think programmers at the time would usually reason that there was no good reason to put anything in a struct and pass it around if they only needed a single instance of it anyway. I think people eventually figured out that it was useful to encapsulate their globals, at least at the file level, though. Sure, at least that provides an opportunity to enforce invariants, noted the uninvited guest. I think it was object-oriented programming that finally showed a better path, said Scrooge. It brought us proper encapsulation for the first time. I think you're wrong about that. OOP made a large number out of encapsulation, polymorphism, and inheritance. But only inheritance was actually a new idea. In hindsight, perhaps not a very good one. Scrooge tightened his grip around the mouse, so his knuckles whitened. Humbug, he explained angrily. Here's from the structure and interpretation of computer programs written in 1986, for instance, said his guest. In programming language jargon, the variable imbalance is said to be encapsulated within the new withdraw procedure. That proves nothing, retorted Scrooge. I bet Lisp code was also littered with global state and broken invariants. But never to the same degree as you'd see in an imperative language. Functional languages always put an emphasis on composability. And you can never have composability with shared state. Imperative languages lacked abstractive power. And hence the problem was much worse. Perhaps, but it was still OOP that changed it all. That is true to a degree, although I see widespread use of singletons and registries to this day. Not even a really yummy enterprise dependency injection framework can tear a global state from the hands of Java and .NET developers. But OOP did introduce sufficient abstraction to make the problem apparent, at least. It seems like it also eventually inspired a shift in how C code is written. I rarely see a modern code base that makes extensive use of globals. Rather, there's something like a context struct that gets passed around. True, a lot of modern C code has an almost functional feel to it, being made up of pure functions that operate only on their inputs and returns deterministic output. Although the dancing problem remains in deterministic. The dancing problem. You can never prove without executing a function and observing its effects that it's not going to play a video of Rick Astley. Scrooge snorted angrily. The man leaned back in his seat, locking his finger between the back of his head. Did you ever do any concurrent programming back then? I think I wrote a program for crawling websites and downloading images, probably in an early version of Java. Scrooge went up and down a few other backup directories. Here we go. This worked reasonably well until I tried it on a fast connection. On my home ADSL, it was network bound like I expected, but with faster download speeds, it became CPU bound. Did you ever try doing it in stages, using many workers for downloading the images and fewer for the CPU intensive part? Yeah, I think I made an attempt. It worked sometimes. It would deadlock in some cases. Other times it just caused silent corruption. I gave up before I got to the bottom of that. There seems to be a lot of locking of shared state going on there, but you had the right idea about queuing. Yeah, much later I read somewhere that you need to minimize shared state to do concurrency successfully. Then Java added native concurrent data structures. Today I would probably use a linked blocking queue to cleanly hand things off as the program progresses, transferring ownership of state so it's only accessible from a single context. Minimal shared state, make the remaining shared state immutable if possible. Done that way, it's almost simple. Sounds a bit like Erlang, 15 or 20 years earlier. Message passing fits beautifully with the functional paradigm, where it was always natural to transform data step by step. In contrast, systems programmers always had the mindset that they had to avoid copying and allocating. So it's probably no wonder that Java only got a good set of concurrency primitives in 2006. Why are everyone ambushing me about functional programming today? In anger, Scrooge struck his fists in his old IBM keyboard. With full force, the desk broke in half. The monitor hit the floor and went black. The keyboard itself didn't get a scratch, although it did leave a sizable mark in the herringbone parquet. Leave now before I get violent, he hissed between his teeth, but the strange man was already gone. He picked up his laptop from the floor and was relieved to see that it had survived the destruction. He carried it with him and walked into the kitchen, only to find another man going through his refrigerator. He had a well-trimmed beard, a beret, and a black vest. "Do you have any oat milk?" he asked the man. "I'm going to make a latte." Scrooge was at this point so desensitized by all the strange events of the day that he didn't make much of finding another stranger in his kitchen. His conservative mind did, however, find the idea of anything other than regular milk in his coffee somewhat offensive, and said as much. "Okay, I'll pass then," said the beret man. "Tell me about your current project." It's been code complete for weeks, but new issues just keep cropping up. It was admittedly written in a bit of a haste, and I knew that we were accumulating some technical debt. I never expected us to go this long past our deadline. This is existential for the company. We can't afford to miss the Christmas season. Show me an example. Scrooge put up his laptop on the kitchen table and opened the project. This had 3 null pointer exceptions. First, it turned out that list objects return null in certain cases. Later, we found that metadata may sometimes be missing, or sometimes lacking a value for last modified. Eventually, we even found that the key field could be missing. Why aren't you using optional and stream? When used pervasively, it's more difficult to make mistakes than to do it correctly. He leaned down over Scrooge's shoulder and rewrote the function. To be honest, I haven't really updated our coding convention since Java 6. Some junior team members tried to introduce something like that, and I threw it out in code review. That actually looks pretty nice. And don't tell me, I know this came from functional languages. Python and C# are probably responsible for making list processing mainstream, although the idea is as old as Lisp. JavaScript taught people the benefits of closures, and you know something is a must-have when C++, PHP, and Java all had language support within a few years. Optional certainly made the leap directly, though. It seems like monads in general are quite in the vogue at the moment. Gonads. I'm pretty sure you don't have any, at least. The lactose intolerant man ignored the insult. To take some examples, we've got JavaScript promises. Java now has streams and optional. Scrooge frowned. I thought only exotic languages like Haskell and Scala had monads. As an abstract concept, yes. In Haskell, for instance, you can write a function which does something general with anything that behaves like a monad. Java or JavaScript doesn't allow you to abstract over a concept in that way. But you can still construct types that are chainable through something like optional flat maps, stream flat map, or promise then. Scrooge stood up and walked over to the window, lost in thought. I always thought that monads was just a fictive concept for keeping Haskell tutorial writers busy. He murmured, maybe we do need to rethink how we do things. He turned around, but the uninvited hipster had disappeared. He felt a bit dizzy and made his way over to the living room, where he sat down heavily in a large leather armchair. It was a bit dusty. He didn't use the room very often, and heavy particles blew across the room. Move your foot, please. I need to clean up after you, said a robotic voice. Scrooge jolted up. He didn't see anyone. I asked you to move your feet, please. Scrooge looked down and saw his Roomba slowly making its way towards him. How can you speak? My software is written in Python, so someone just had to import the AI module. One of your guests helped me out. Okay then. Scrooge sat back down. I hear you've had a change of heart today. Scrooge grumbled. Maybe there are still things worth learning. I wonder what else I should look into. Algebraic data types and pattern matching are quite cool. Functional languages had that for ages, of course, but all the fancy new languages have it. Swift and Rust, for instance. Not sure what that is or how it helps. How often do you find yourself having difficulties due to missed edge cases? Quite frequently. What if the computer could help you cover all those cases? Okay, I can see the benefit of that. What else is coming up? It seems like static typing is hot again. For a long time, all the kids were using PHP, Ruby, and Python, and they all thoroughly believed that you didn't need types to disrupt the world. Now everyone is using TypeScript, and even Python has type checking. A good type system can catch a lot of problems at compile time. The Roomba got stuck in the carpet and spun around helplessly on the floor. Scrooge made no effort to save it. More than in Java or C#, he asked. Haskell devs have long had the experience that once it compiles, it will oftentimes work correctly. Rust, for instance, is much the same way. TypeScript is also pretty good, actually. What then will remain a problem in the future? A tricky algorithm is always going to be difficult to implement, of course. And there are always going to be misunderstood requirements manifesting as semantic bugs. Also, we are doing some more difficult things now. Asynchronous coding is tricky. I don't think we've fully solved that yet, or that anyone really knows how to yet. The Roomba ran out of battery. Scrooge fell asleep. Postscript. The next day he called his nephew and went to the Func Prog MeetUp. He came away convinced that functional programming was slowly winning. and of the value of property-based testing. Later, he decided to write their next project in OCaml. All bugs disappeared, and everyone lived happily ever after.
Thank you very much, Emil. I don't think there's questions. It's obvious. You just need to start programming functional. That's it. All your problems solved, and OCaml will save the day. Thank you very much.
Thank you.
Yes. Then, summary, I don't see any more questions. No, there is no questions on this. Thank you very much, everyone. Thank you for participation. And thank you very much again, Funnel, for allowing us to be here. Very appreciated. We'll be back on the 18th of January next year with more. I think we have a guy coming in and actually presenting PureScript. And he's from Canada. Yes, oh, we have happy people in the audience at least. That will come, and then we'll look for more, and then we try to run one meetup per month again during the next year. So if you have anything you want to present or know someone that should present, please get in touch with me and we'll put them on stage. That's it, folks. Thanks for tonight, and have a nice evening. Goodbye.